by PTI Los Angeles, published December 10, 2017, 6:14 p.m. Scientists have proven the existence of new form of matter called excitonium, which was first theorized almost 50 years ago. Researchers from University of California, Berkeley and University of Illinois at Urbana-Champaign in the U.S. studied non-doped crystals of the transmission metal dicalled cogenide titanium diselenide 1Ts2. Excitonium is a condensate. It exhibits macroscopic quantum phenomena, like a superconductor. It is made up of excitons, particles that are formed in a very strange quantum mechanical pairing, namely that of an escaped electron and the hole it left behind. It defies reason, but it turns out that when an electron, seated at the edge of a crowded with electrons valence band in a semiconductor, gets excited and jumps over the energy gap to the otherwise empty conduction band, it leaves behind a hole in the valence band. That hole behaves as though it were a particle with positive charge, and it attracts the escaped electron. When the escaped electron with its negative charge pairs up with the hole, the two remarkably form a composite particle, a boson, an exciton. In point of fact, the hole's particle-like attributes are due to the collective behavior of the surrounding crowd of electrons. However, that understanding makes the pairing no less strange and wonderful, researchers said. Until now, scientists have not had the experimental tools to positively distinguish whether what looked like excitonium was not in fact a Peale's phase. Peale's phases and exciton condensation share the same symmetry and similar observables. Abamonte and his team were able to overcome that challenge by using a novel technique they developed called momentum-resolved electron energy loss spectroscopy (MELS). With new technique, the group was able to measure collective excitations of the low-energy bosonic particles, the paired electrons and holes, regardless of their momentum. Ever since the term excitonium was coined in the 1960s by Harvard theoretical physicist Bert Halperin, physicists have sought to demonstrate its existence, said Peter Abamonte, professor at University of Illinois. Theorists have debated whether it would be an insulator, a perfect conductor, or a superfluid, with some convincing arguments on all sides. Abamonte said. Since the 1970s, many experimentalists have published evidence of the existence of excitonium, but their findings were not definitive proof and could equally have been explained by a conventional structural phase transition, he said. The findings, published in the journal Science, holds great promise for unlocking further quantum mechanical mysteries, researchers said. It could also shed light on the metal-insulated transition in band solids, in which exciton condensation is believed to play a part. Beyond that, possible technological applications of excitonium are purely speculative. For all the latest technology news, download Indian Express app.